Many people know about black holes and how terrifying they can be with their unending appetite for swallowing anything that's unfortunate enough to come close. However, many do not know about the counterpart known as a white hole, which is just as terrifying. For decades, the existence of white holes has been theoretical, but that has now changed with scientists' first ever discovery of a white hole. What are white holes, how do they work, and how are they different from black holes? But most importantly, is planet Earth in danger from white holes? Join us as we dive deep into the scary world of white holes that just opened up thanks to new scientific discoveries. Deep space is a scary place, and there are many objects that will try to kill you. Some will bombard you with harmful radiation, while others are surrounded by noxious gases that will asphyxiate you. However, one particularly terrible space object will swallow you up forever. This is the nightmare known as a black hole. Equally nightmarish is the counterpart to a black hole known as a white hole. These two objects share many similarities and differences, and to understand white holes, which this video is about, you must know about black holes. A black hole is a region in space where the pulling force of gravity is so strong that even light is not able to escape. Black holes are mind-bogglingly numerous, and the Milky Way galaxy alone could contain over 100 million of them. Other estimates say 1 billion. There is a super large one located at the center of our galaxy, known as Sagittarius A star. This colossal structure is about 4 million times the mass of the Sun and is about approximately 26,000 light-years away from Earth. While we have known about black holes for many years, it wasn't until 2019 that we got the first image of one. It was captured by the Event Horizon Telescope EHT collaboration. The striking photo of the black hole at the center of the M87 galaxy, 55 million light-years from Earth, thrilled scientists around the world because black holes are difficult to detect. The first black hole ever discovered was Cygnus X1, located within the Milky Way in the constellation of Cygnus the Swan. Astronomers saw the first signs of the black hole in 1964 when a sounding rocket detected celestial sources of X-rays. The closest black hole to Earth is known as the Unicorn and is situated approximately 1,500 light-years away. Where do black holes come from? Pay attention here because we will touch on something similar when we get to white holes. Actually, the way a black hole is formed determines the size. For example, there are stellar black holes, which in the League of Black Holes are small, but they are deadly. When a star burns through the last of its fuel, the object may collapse or fall into itself. Smaller stars, about 3 times the Sun's mass, will transform into neutron stars or white dwarfs, but the bigger star continues to compress until it forms a stellar black hole. This type of black hole is relatively small but very dense. For context, one stellar black hole the size of a city can pack 3 times the mass of the Sun. As a result, the dead star exerts a tremendous amount of gravitational force on the objects around it. You can also have supermassive black holes, which actually number more than stellar black holes in the universe. They can be millions or even billions of times heavier than the Sun, even though having the same diameter. This is the type that is at the center of most galaxies. Up until now, scientists have not been sure how the supermassive black holes form, but they're always accumulating mass from the dust and gas around them. Some theorists say they are produced from the merging of hundreds or thousands of smaller black holes. Others postulate they are formed from dark matter. Another type of black hole is intermediate. They can form when stars in a cluster collide in a chain reaction. However, intermediate black holes can also collapse together to form larger black holes. At this point, you're probably wondering if the Sun, which is a star, can turn into a black hole and what that could mean for the Earth. The good news is that would not happen. This is because the Sun does not have enough mass to collapse into a black hole. In billions of years, when the Sun is at the end of its life, it will become a red giant star. Then, when it has used the last of its fuel, it will throw off its outer layers and turn into a glowing ring of gas called a planetary nebula. Finally, all that will be left of the Sun is a cooling white dwarf star. What do black holes look like? This part is also essential because of some similarities with white holes. Black holes comprise 3 layers: the outer and inner event horizon and the singularity. The first one, the event horizon, is the boundary around the mouth of the black hole. It is significant because once past it, nothing can escape, including light. Once a particle crosses the event horizon, you can just kiss it goodbye. Scientists say gravity is constant across the event horizon. The inner region of a black hole where the object's mass lies is known as its singularity, that is, the single point in space-time where the mass of the black hole is concentrated. Scientists can't see black holes the way they can see stars and other objects in space. Remember that not even light can escape from it. However, they are detected through the radiation they produce as they pull in dust and gases. But supermassive black holes lying in the center of a galaxy may become shrouded by the thick dust and gas around them, which can block the telltale emissions, making them even more difficult to locate. But there is an event that could give up the position of a black hole. Sometimes the objects drawn by a black hole will strike the event horizon and bounce out instead of ending up in the belly of the black hole. When this happens, it produces bright jets of material traveling at near relativistic speeds. These jets can be seen from afar, although the black hole itself remains hidden. So hopefully now you would understand when we say white holes are the opposite of black holes. This means nothing can go inside a white hole, the opposite of how nothing can escape a black hole. Think of this as a massive cosmic yin-yang, or more practically, the edge of a black hole is a point of no return, while the edge of a white hole is a point of no admission. How exclusive is your club? Remember we said black holes and white holes have a lot in common. Well, if you're in a spaceship at a safe distance, of course, a white hole looks exactly like a black hole. For instance, it has mass and might also spin. You may also observe a ring of dust and gas gathering around the event horizon. Yes, a white hole also has an event horizon forming the boundary with the rest of the universe. However, if you stay to watch long enough, you will notice the difference. With the white hole, you will notice a belch, something a black hole cannot do. But of course, white holes can be described as the time reversal of black holes. This makes white holes fascinating because nothing from outside can affect what is going on inside them, so they are some of the most original objects in the universe. Much focus has been placed on black holes, but recently scientists have been delving into white holes too, and many fascinating discoveries have been made. However, some of this work is in the opposite direction, that is, trying to prove white holes don't exist. Why do these scientists claim white holes cannot exist theoretically? A black hole cordons off its bit of space when a star collapses into a tiny volume, but playing this video backward doesn't make any physical sense. An event horizon exploding into a functional star would look a bit like an egg unscrambling itself. This is practically a violation of the statistical law that the universe gets messier over time, not more orderly. Also, even if large white holes did form, they probably wouldn't exist for too long. Any outgoing matter would collide with the matter in orbit, and the system would collapse into a black hole. However, there are stronger reasons for the existence of white holes. First, white holes could come from black holes. Sounds incredible because of the opposite ways the two operate? Well, hear us out first. Ever since Stephen Hawking discovered that black holes leak energy, physicists have wondered how these black holes could shrink and die. One of the perplexing questions that have to be answered in the scenario is, if a black hole evaporates away, many ask, what happens to the internal record of everything it swallowed? The thing is that general relativity says the information can't come out, while quantum mechanics says it can't be deleted. What a dilemma! But theoretical physicists have another way to look at it, which would explain the birth of white holes. He asks, how does a black hole die? We don't know. How is a white hole born? Maybe a white hole is the death of a black hole. The two questions join nicely, but you have to violate the general relativity equations in the passage from one to the other. Does that not sound neat? Rovelli is a founder of quantum loop gravity, an incomplete attempt to move beyond general relativity by describing space itself as built from Lego-style particles. Guided by tools from this framework, he and others describe a scenario where a black hole grows so small that it no longer obeys the common-sense rules of stars and billiard balls. On the particle level, quantum randomness takes over and the black hole could transform into a white hole. This white hole could just be the size of a human hair, but it will be hiding a cavernous interior containing the information of everything it had swallowed in its previous life. Since it will be too small to attract orbiting matter, the white hole might remain stable enough to eventually spit out all the information accumulated by its forerunner. There is an interesting outcome in this scenario because it means at a point, obviously billions if not trillions of years from now, the universe will be dominated by white holes after all the stars have collapsed and the resulting black holes have withered. Even at the basic level, we might be living in a white hole world. This is because the Big Bang Theory, which is the explosion of matter and energy, is classic white hole behavior. As one scientist puts it, the geometry is very similar in the two cases, even to the point of being mathematically identical. Let's hear what you think of white holes in the comments section below.